Welcome, students. Today we're going to be looking at function notation, which comes up a lot throughout the school year, so it's really important that you understand what it is and how to use it. Function notation is a way of naming a function. Traditionally, we use the letters F, G, or H, so you're probably used to seeing f of x like this in some other math classes you've taken. But you could use any letter, name, or word instead. So here's some examples. So here's a pretty basic one. F of x equals 2x minus 1. So you've got x, that's your basically your inputs. Your rule is 2x minus 1. So I have some values that I need to put into my function, into my equation. Those are my inputs. And the rule I'm doing to them is that I'm multiplying it by 2 and then subtracting 1. So whatever my input is, I multiply by 2, subtract 1. That's the rule. Now I'm calling this rule f. So the name of this rule is f. It's not a very interesting name, but that's okay. It doesn't have to be interesting. It just has to be clear. So this rule, 2x minus 1, is now named f. And all that really means is y equals 2x minus 1. So that's something that you could graph on your calculator or on a grid. It just means the same thing as y equals 2x minus 1. That's it. So you've probably heard something like f of x is the same as y, and that's kind of what that's referring to. So instead of calling all these rules y, they each have their own name. That's all that means. So the next one. So g of a equals a squared. So my input, and it's here too. That also tells you what the input is. The input is a. My rule, in this case, is a squared, so a times a. And I have named this rule g. So the name of the rule is g. The rule itself is a squared. And that just is the same as if I were to say y equals x squared. It means the same, but this is just more clear because the function has a name of its own instead of everything being called y. Okay, example 3. H of x equals x plus 3. So my input is x. So if I want to input a value into this rule, I'm going to put it in for x. And the rule, so what's the rule that I'm doing to x? So the rule is x plus 3. And then what's the name of this function? So the name of the function is h. And what does that mean? It's the same as if I said y equals x plus 3. Example 4. So I did say up here, usually we use f, g, or h as our function names, but you can really use anything you want. So on example 4, I've called my function Larry. So my input, I'll be careful here because you got an x squared and an x, and it might be a little confusing, but my input is still x. So if I were going to put a value into this function and plug it in and see what my output is, I would put the value in for x. So the input is x. The rule is x squared plus x, and the name of the function is Larry. Larry. And that means the same as y equals x squared plus x. So here's something else you've probably seen before. What does it mean when a problem asks you to find f of 2? What's it asking you for? So notice that up here we said that these, in fact, let me go ahead and draw that arrow that I skipped before. This part in the parentheses tells you what the input is. So when they put a number here instead, all they're telling you is take the rule named f. So the rule named f is this one right there, because I called it f, so I know which one it is. And all that means is put 2 in for x. That's it. So let's try it. So find f of 2. Let's actually fill in the sentence here first. It means find the value of the function named f when the input value is 2. So let's do that one. Find f of 2. So rule f is 2x minus 1. So go ahead and I'm just going to jot that down so I can see it more easily. Okay, so I just jotted that down here so we can refer to it. And I want to find the value of this rule when x is 2. So I'm going to do f of 2 equals 2. Instead of 2 times x, I'm not going to write x. I want to write 2. So 2 times 2 and then minus 1. And 2 times 2 is 4, minus 1 is 3. So f of 2 equals 3. That's all there is to it. Why don't you see if you can do this one? And then the solution will be available for you after you've tried it yourself. So go ahead and check and see if you got it right. Let's try number 7. Oh, we're working with rule G. So let's find rule G. Rule G is g of a equals a squared. So I'm going to write that down, just so I can see it easier, that's all. You wouldn't necessarily have to rewrite everything like that. I just can't show these both at the same time on the video. So, all right, so my input is 0.5 or 1/2. You can use fraction or decimal, whatever you're more comfortable with. So I'm just going to put that value in for a, everywhere I see a. So I have g of 1/2 equals, and instead of a squared, I'm going to write 1/2 squared or 0.5 squared. And 0.5 squared or 1/2 squared is 1/4, a quarter. So g of 1/2 equals 1/4 or 1/4. So I want you to see if you can try number 8, see if you can do it yourself. And then you can check it after you've tried to answer it. So check and see if you got -4, and here's the steps I used to get there. Example 9. Oh, we get to work with Larry. Well, let's go up and find rule Larry. Okay, so Larry is x squared plus x. So I'm just going to jot that down. Larry of x equals x squared plus x. Okay, so I want to find the value of the rule Larry when x is 4. So everywhere I see x, I want to put a 4. So be careful, x appears in 2 spots, so make sure you put 4 for both of them. So instead of x squared, I have 4 squared and plus 4. 4 squared is 16 plus 4 is 20. So Larry of 4 equals 20. So number 10. Now check out the difference here. Instead of having a number, instead of replacing x with a number, I'm replacing x with another expression. So I'm almost putting a rule inside another rule, which by the way is called composition of functions. Which that's something, if you take pre-cal, you'll learn more about that, but I just want to kind of throw that term out there. That's what it's called. Okay, so find f of x squared plus 1. So first, as usual, I want to write down f of x so I can point to it easier. Okay, so there's my rule f. So I just copied it from up here. It's the rule named f. So I want to replace x in this rule with x squared plus 1. So f of x squared plus 1 equals, and I have 2, so it would normally be 2 times x, but this time it's going to be 2 times x squared plus 1. So 2 times x squared plus 1. And notice I did put parentheses there, so the 2 multiplies by both those terms. And then minus 1. Now technically you can usually stop there. I would accept that for now, but some of you are going to want to simplify it, especially if you're planning to take the SAT, hint, hint, you want to get used to simplifying things a little bit more. So to simplify this, we're going to distribute the 2. So 2x squared, and then 2 times 1 is just 2, and then just minus 1. And then 2x squared, and then 2 and negative 1 are like terms, so you can combine them. So 2x squared plus 1. And that would be the simplified form of this. Number 11. So we're going to do kind of the same thing here. We're going to compose these two functions. So we have rule G, and we have this other rule 2a. So we're going to be replacing a with 2a. So let me go find rule G. What's it look like? Oh, it's a squared. So I'm going to jot down G of a equals a squared. So wherever I see a in my rule, I'm going to put 2a. So G of 2a equals, instead of a squared, I'll put 2a squared. Notice again I put parentheses so that the 2 and the a both get squared. Again, that's acceptable for now, but simplified, you're going to want to square this whole thing. So 2 to the second power is 4, a to the second power is a squared. So 4a squared would be the simplified answer. Okay, finally, example 12, Larry. Let's write down the rule Larry once again. So rule Larry, the rule is x squared plus x. So I want to replace x inside this rule with x minus 3. So everywhere I see x, I'm instead going to write x minus 3. So you're going to want to use parentheses like we did over here, because you're squaring an x. Here we were squaring an a, so make sure you put it in parentheses. So x squared, I'm actually going to put x minus 3 squared. And then plus x, so plus x minus 3. And you can put parentheses here or not. Order of operations doesn't change, so it really doesn't matter. Oh, I didn't write the other side. Larry of x minus 3. Sorry, that's messy. It was squished together. Now, I would accept this once again. For now, I would accept that. Now, later in the fall, we're going to review how to square a binomial like this, which you did in Algebra 1, but you may not remember it. So after that time, I would expect you to simplify this, but for now, we can just leave that alone. And if you do want to know how to simplify it just for your own education for now, then just let me know. I'll come over and show you.